Hello students. uh, in this video, I'll explain assignment number 5 of first chapter of uh, chemistry. Uh, this assignment includes numericals on multiple proportions, Gay-Lussac's law and Avogadro's law. First numerical. 3.45 grams of a yellow oxide of lead gave 3.21 grams of lead on reduction with hydrogen. Reduction means removal of oxygen. 1.191 gram of brown oxide lost 0.155 gram of its weight in a similar experiment. It means these two are different oxides of lead. One is yellow oxide and the other is brown oxide. And we have to justify that this data corresponds to law of multiple proportions. Now, lead oxide, yellow and brown. Lead, oxygen, yellow oxide 3.45 grams. On reduction gives 3.21 gram of lead, 3.21 gram. It means this minus this is oxygen. Oxygen is 0.24 gram. Brown oxide 1.191. Lost 0.155 gram of weight in a similar experiment. It means oxygen was 0.155 gram. It means this minus this was lead. After you subtract, this will come out to 1.036 gram. I'll fix the quantity of one of the two elements. Let us say we fix the quantity of lead, 3.21, 3.21, 0.24. It means no change in the first data. In the second case, we'll calculate by applying unitary method. 1.036 combines with 0.155 gram of oxygen. 3.21 combines with how much? So this will be 0.155 divided by 1.036 into 3.21. This will come out to 0.48 gram. Now, same mass of lead combines with different masses of oxygen. Now, ratio of these different masses of oxygen is a simple whole number ratio, that is 1:2. Ratio is 1:2, and therefore it proves the law. Second numerical. 3 different hydrocarbons contain so and so % hydrogen. Show that the data illustrates law of multiple proportions. Hydrocarbon number 1, 2, and 3. Hydrogen is 25%. It means carbon 75. Second case, 14.28% hydrogen. It means carbon will be 85.72%. In the third case, it is 7.69% hydrogen. It means remaining 92.31 will be hydrogen. Let us fix the quantity of hydrogen at 25 grams. So no calculation in the first case. It will remain 75. In the second case, it will be 85.72 divided by 14.28 into 25. This will come out to 150. Third case, 7.69 combines with this much. So 92.31 divided by 7.69 into 25. This will come out to 300. Ratio of these different masses of carbon which combine with same mass of hydrogen is a simple whole number ratio. This ratio will come out to 1:2:4, and therefore proves the law of multiple proportions. Third, 22 and 30 grams of two different oxides of nitrogen gave 11.2 liters of nitrogen at STP. Show that the data illustrates law of multiple proportions. Nitrogen oxide number 1, oxide number 2. This is 22 grams and the other one is 30 grams. Nitrogen in both the cases is 11.2 liters of nitrogen at STP. It means 11.2 liters will be half mole of nitrogen. Molecular weight of nitrogen is 28. It means half mole will be 14 grams of nitrogen. 14 grams, 14 grams. Because this is 11.2 liters. This minus this is oxygen. This minus this is oxygen. So same mass of nitrogen combines with different masses of oxygen, and the ratio is a simple whole number ratio, therefore proves the law. Fourth numerical. Now in this numerical, we'll talk something about higher oxide and lower oxide. If we consider carbon, carbon monoxide is the lower oxide of carbon, carbon dioxide is the higher oxide of carbon. So when we convert carbon into carbon monoxide into carbon dioxide, quantity of carbon does not change, quantity of oxygen increases. Similarly, when we reduce, CO2 changes into CO, CO changes into C, that is quantity of oxygen will decrease, quantity of carbon does not change. It's the same type of numerical. 5.975 gram of a higher oxide gave 5.575 gram of lower oxide on partial reduction. Like we convert CO2 into CO, that is called partial reduction. And if we convert CO2 into carbon or we convert CO into carbon, that is called complete reduction, means complete removal of oxygen. And 1.175 gram of metal on complete reduction. Show that the data illustrates multiple proportions. So metal oxide, higher oxide, lower oxide, 5.975 grams, 5.575 grams. Lower oxide obtained is 5.575 grams. Ultimately, metal obtained is 5.175 gram. It means both contain the same quantity of metal. Quantity of oxygen is different. This minus this is oxygen in the higher oxide. This minus this is the quantity of oxygen in the lower oxide. Same mass of metal, different masses of oxygen. Ratio of masses of oxygen is 2:1. It's a simple whole number ratio. Next numerical. A metal forms two different oxides. Higher oxide contains 80% metal. 0.72 gram of lower oxide gave 0.8 gram of higher oxide on oxidation. Let us write the data. Metal oxides. Higher oxide, lower oxide. 0.72 gram of lower oxide gave 0.8 gram of higher oxide on oxidation. Naturally, quantity of oxygen might have increased, quantity of metal does not change. And quantity of metal in the higher oxide is 80%. So 80% of 0.8. 80% of 0.8, 0.64. It means metal is 0.64 gram, which is present in lower oxide as well. It means oxygen will be this minus 64.16, this minus 64.08. Same mass of metal combined with different masses of oxygen, and the ratio is a simple whole number ratio 2:1. Next. This is based on equation. Let me write the equation first. N2 gas plus 3H2 gas gives 2 ammonia gas. How many liters of ammonia will be produced by reacting 300 liters of hydrogen with nitrogen according to the following equation? By reacting 300 liters of hydrogen, this is 300 liters, and volume of ammonia we have to calculate. See, according to Gay-Lussac's law, ratio of volumes of hydrogen and nitrogen, ratio of volumes of hydrogen and nitrogen is 3:2. It means this you have to explain properly, right? So according to Gay-Lussac's law, 3 liters of hydrogen will produce 2 liters of ammonia. 300 will produce how much? That is your answer. It will come out to 200. Next numerical. Equation is 4NO gas plus 3O2 gas gives 2N2O5 nitrogen pentoxide gas. Calculate volumes of NO and O2. These volumes we have to calculate to produce 50 liters of N2O5. Again, you have to properly explain. I'm explaining verbally. To produce 2 liters of N2O5, 4 liters of NO is required. And to produce 50 liters, how much will be required? It will be double, that is 100 liters. That is one answer. Second, to produce 2 liters of N2O5, 3 liters of oxygen is required. And to produce 50 liters, how much is required? You calculate, this will come out to 75 liters. So these are two answers. Next. There are two equations involved. Let me write equations. C3H8 gas plus 5O2 gas gives 3 CO2 gas and 4 water. This is equation 1. Second is C4H10 gas plus 13/2 O2 gas gives 4 CO2 gas and 5 water. In both these equations, except water, all reactants and products are gases. 5 liters mixture of propane and butane. Mixture of these two is 5 liters. Produce 17 liters of carbon dioxide on complete combustion. So total carbon dioxide produced is 17 liters. Calculate percentage composition of the mixture. Say propane is X liters. Therefore, butane will be 5 minus X liters. Now let me label, yes, these are equations 1 and 2. Volume of CO2 according to equation 1. Say, Gay-Lussac's law. 1 liter gives 3 liters. X liters will give 3X liters. Volume of oxygen according to equation 2. 1 liter gives 4 liters. 5 minus X will give 4 into 5 minus X liters. Now, if I add these two, it will be equal to 17. It means 3X plus 4 into 5 minus X is equal to 17. Calculate the value of X. This will come out to 3. It means out of 5 liters mixture, propane is 3 liters. So percentage of propane will be 3 divided by 5 into 100, that is 60%. And percentage of butane will be 100 minus 60, that is 40%. Now coming to theoretical question number 1. Vessels A and B containing O2 and O3 respectively have same capacity and maintain at the same temperature and pressure. Which of the two vessels contain more number of molecules? See, according to Avogadro's law, equal volumes of all gases at same temperature and pressure contain equal number of molecules. So both of them contain equal number of molecules. That is the answer for A part. B part is atoms. Which of the two contains more atoms? Since one molecule of ozone contains more number of atoms than 1 mole of O2, and both vessels contain same number of molecules, naturally number of atoms present in vessel B will be more than in vessel A. State Avogadro's law. How is it different from Berzelius hypothesis? This you'll find directly in your notes also. Avogadro's law says that equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules, whereas according to Berzelius hypothesis, everything is same. Towards the end, it says contain equal number of atoms, right? So that's all about this assignment.